smallest particles is now increasingly coming into focus. How does reality work? People have always wanted to know why we are here and how this world works. In the past, churches and religions provided explanations. But for about 300 years, stories from the Bible and other myths seem to have become obsolete. The natural sciences were born and tried to explain and prove our reality through numbers, formulas, and repeatable experiments. Even in the last century, Einstein, at the beginning of his research, thought fixed stars were firmly anchored in space in some kind of mass or field. He searched meticulously for constant sizes at which he could have oriented himself. But instead of constancy and fixed quantities, he found motion, rotation, relativity, and dependencies. By the way, it was he who could first describe quanta in further detail. For his light quantum hypothesis, he received the Nobel Prize for Physics in 1921. Later, he didn't like quanta anymore. They behaved much too unpredictably. The overflowing findings of quantum physics seemed to finally destroy Einstein's great dream of a unified formula for describing reality. Crazy quantum world. Since humans began to investigate quanta, some physical foundations have begun to shake. That's exactly why a determinist like Einstein had a hard time with it. In determinism, scientists like to bring things to the point. Quantities must be precisely describable. Only what can be experimentally repeated and calculated is considered real. Quanta, on the other hand, do the following. Atoms, molecules, and thus all matter visible to us is composed of elementary particles like quanta. You've probably also heard of the double-slit experiment. Before the findings of this experiment, physicists assumed that electrons and quanta were particles. That is, reasonably determinate. They exist, form a point, albeit a tiny one, and have a specific shape and purpose. In the double-slit experiment, it turned out that electrons are not solid particles, but behave like waves. Only when you want to measure them do they settle down. The German physicist Werner Heisenberg did research in the 1930s. He tried to calculate the orbits of electrons in atomic nuclei. But in the end, he discovered that electrons do not follow any paths at all. Only when they're observed do they form in certain patterns. Heisenberg came to the conclusion that human observation itself corresponds to a measuring process which influences the world of the smallest particles. He formulated this sentence: observation itself selects from all possible processes the one that actually took place. To put it yet a little more simply, this means, if nobody observes the material basic components of the world, they behave like a wave with an indeterminate potential. Got it? For you personally, this would mean, for example, that you yourself are only there because you can perceive, or in other words, measure yourself. A table, which stands in front of you, would be there only as long as you measure it, thus see it. If no one is there to perceive it, it dissolves into a wave-like potential. Einstein raged indignantly at the time. Yes, you want to say then that the moon does not exist if nobody looks. So this has been a small excursion into the history of science. But you need this information to understand the thought experiments about the existence of two or more realities. Schrödinger's cat. The findings of the unpredictability or flexibility of the quanta are already about 100 years old. Of course, these findings heated up the discussions about the nature of reality itself. If realities change by measurements of observers like we are, there should logically be several realities. Indeed, the measurement itself is strongly related to our personal expectations and intentions. That's to say, your will and goals affect quanta. In 1935, Erwin Schrödinger set up a thought experiment. In a box, there was a cat. Next to it was a kind of electron bomb. It consisted of a radioactive compound, a measuring device with an integrated drop hammer, and a bottle of poison. If the material were to decay within the experimental period, the hammer would be triggered, which would destroy the bottle with the poison and the cat would die. Making radioactive material decay by observation is roughly equivalent to Heisenberg's observation of electron orbits. Consequently, Schrödinger, as the experimenter, could influence the outcome by his observation. Schrödinger's point was that in the world of quanta, both outputs of the experiment would be present until an observer measured them, bringing a variant into reality. Up to this point, the cat would have to have been a wave-shaped potential, thus theoretically dead and alive at the same time. The Wigner's Friend Experiment. The US-American physicist Eugene Paul Wigner went a bit further in the 1970s. He used two observers. Wigner himself performed an experiment similar to Schrödinger's cat. Wigner's friend knew about this experiment. However, he was not in the room when Wigner himself measured or better determined the outcome of the experiment. Wigner's friend was standing in the hallway. Theoretically, the realities of Wigner, who had already determined the outcome, and his friend, who had not yet made a visual measurement, should have coexisted for a while. For physicists of the old school and followers of determinism, such ideas are somewhere between insanity and scientific blasphemy. Nevertheless, if one believes the findings of quantum physics, this would be more real than the existence of only one reality. Even more, who says that the cat does not also measure and determine the outcome of the experiment by its mere living presence? The measurement problem of quantum physics. Some questions remain, such as, what if Wigner's measurement doesn't match his friend's, and who is actually measuring with what? Do we all perceive the same world? And more importantly, do we all live in the same world? It is still unclear what exactly measures when humans observe things. Is it the will? The expectation? Is it the thoughts, fears, the subconscious? Or is it a mixture of all of them together? In philosophy, thought experiments and quantum insights have led to wild speculation. Although a horror to many scientists, disciplines such as mind science and the eternal question of who we ourselves actually are as humans are coming together again. Open your mind a bit and imagine this. Either Wigner's measurement matches that of Wigner's friend, and they both continue to live in unison in the same reality, or their paths part at the point where they consciously decide to measure or choose different realities. This sounds crazy, but this is exactly the theory of multiverses. It is supported by renowned physicists all over the world, not only by crackpots. According to this, innumerable variants of the universe and our real experience exist presumably next to each other. Again, there is a disagreement among experts whether the different system states are superimposed in one world or whether they are distributed across several worlds. Another US physicist named Hugh Everett posited the many worlds interpretation. As soon as we measure, we choose a world. In doing so, we may unconsciously navigate through different worlds that meet. Or we may slowly arrive at worlds that, when observed from the outside, would be quite different from our initial world. But the ideas and possibilities provided by quanta go one step further, because presumably, we do not exist only once. Physicists like to explain the phenomenon in terms of flipping a coin. Imagine flipping a coin in an infinite number of universes that are identical, similar, or completely different. In the identical universes, the result splits into two groups, heads or tails. Depending on the result, your reality evolves. However, the innumerable other variants also exist. Imagine these possibilities. The coin doesn't land in your field of vision at all, it just disappears. A group of terrorists enters the room and shoots you before you can find the exit. You simply throw the coin away, say, "What nonsense, nobody understands that anymore," and indignantly leave the room. Accordingly, The Matrix would have been more of a documentary than a science fiction film. Does consciousness determine? By the way, the world has long been interpreted in a very similar way by some wisdom traditions and mystery schools. The scholars and sages of these circles already assumed thousands of years ago that the creation contains all possibilities at the same time. In these models, time, as we experience it every day, does not exist either. Strictly speaking, everything takes place simultaneously. The illusion of time is a kind of projection that allows you to experience reality. Thus, man is an embodiment of creator consciousness itself and navigates the spaces of creation through experience, interpretation, decisions, actions, and emotions. So it seems that modern quantum theories and ancient knowledge are merging together here. Are you confused now, or do you feel scientifically enlightened? The thought that your measurements decide your reality is infinitely interesting. Imagine that you could make or choose a reality that you prefer. What do you think about it? Let us know your opinions and post your ideas on the topic in the comments section.